Today we're going to look at similar figures and how to identify the scale factor of these similar figures. So what is or are similar figures? These are any shape where they have congruent corresponding angles, but notice the corresponding sides are proportional. So they're all going to create and make the same ratio with each other. So these are figures that will appear to have the same shape, but they will be different sizes. All right, so same shape, different sizes. That's how they will appear. All right. This is right here is called a similarity statement. So when you're asked to write one, just like you were when we did congruent figures, all right, you're going to have some shape. And then this is our symbol for similar. It looks like the one for congruent, but we take out the equal sign. It's just the squiggly. All right. And then that will be similar to another shape. The way they are written tells you how the angles match up, right? So the first letter goes with the first letter, the second goes with the second, and so on and so on. And the same with the side. So side AB isn't going to be congruent to side XY, but it's going to be proportional. So we're going to make a fraction with those two sides. And then we'll make a fraction with the second and third letters together, and the third and fourth, and so on. So looking at this, I know that angle A is congruent to angle X. All right, remember the angles are still congruent. I know angle B is congruent to angle Y. Angle C will be congruent to angle Z, and angle D is congruent to angle Q. Now the sides are proportional. So let's start with the first. So I know side AB is proportional, so it's going to make a ratio with side XY. And whatever that ratio is, it's going to equal whatever side BC is over YZ. And it will equal the same ratio as side CD over ZQ. And then if we go back and grab the first and the last, so side AD is going to make a ratio with XQ. All of these ratios for all four sides, or however many sides our figure has, must all be the same. If three are the same and one is different, then these would not be similar to each other. This ratio that is made is our scale factor. So the ratio of any pair of corresponding sides or parts, all right, because you might have an altitude drawn into a figure, or a median, or a mid-segment, anything. Any of those parts are going to share the same ratio as the sides if your figures are similar. So when it says find the scale factor from one shape to another, you're writing a ratio. The order is important. So this first would be our numerator, the second would be our denominator. All right, so here's our shapes. So when I look at this, I see I have side AD given. Well, according to my pattern, AD should go with EH, but there's nothing written there. All right, so I need to move on to another side. So I'll look at side DC, and side DC goes with HG, which I do have. So these are the two numbers that I can use to help me write my scale factor. So the number from figure ABCD is my numerator. EFGH is my denominator, and then I reduce that to get a scale factor of 3:2. This also tells me in this order that the first figure, ABCD, should be larger than the second, simply because this is a number bigger than 1. All right, so first shape was larger. If they have us reverse it and they want the scale factor of figure EFGH to figure ABCD, then I would do 4/6 to start, which reduces to 2/3. So again, when you look at this, because that is a fraction less than 1, this is telling you, in this case, that the first shape was the smaller. Next figure, we've got two triangles. It wants the scale factor of triangle SUN to triangle HOT. So I'm going to look at side SU, and according to my pattern, that goes with HO. So I can use those. So if I go triangle sun to triangle hot, I'm doing 3/6, which reduces to 1/2. So my first shape should be smaller than the second one. This time they want us to reverse it. They want us to do triangle HOT to SUN. So this time I would do 6/3, which reduces to 2/1. This is the only time where you can actually leave a number over 1 and won't get, told not to do that, because it's nice to see the ratio. And then of course this is showing us that the first shape, triangle hot, is larger, twice as large as the smaller one. When it says to write a similarity statement, all right, that means pick any way to name your first shape. And I'm going to intentionally not do it as SUN. So I'm going to do NUS. So if that's how I choose to name my first, then that's going to be similar. And I want corresponding parts together. So N goes with T, U goes with O, and S goes with H. So that would be one possible similarity statement. All right. Again, we could have just done the easy triangle sun to triangle hot, but there are others. Okay. In number 6, we're told that the triangle has an extended ratio of 2 to 3 to 4. So we want to know which of these other ratios would be similar without actually having a picture. Now notice if I've got 3 different side lengths, this is a scalene triangle. So when I look at my choices and I see 3, 3, 4, I know this one is isosceles. So this one's definitely not similar because remember it has to stay the same shape. This one might be, 6, 8, 10 might be, 4, 6, 8 might be, but 4, 4, 4, this one's equilateral. So again, these are not similar. Now, how do I check the ones that might be? So just to keep it simple, I'm going to leave the 6, 8, 10 there as my numerators, and I'm going to put the 2, 3, 4 underneath. Now, how do I know they match up like that? Because I'm looking at my shortest, my medium, my longest. So that's going to go with my shortest, my medium, the medium, my longest. And then when I reduce these, I get 3 to 1. That doesn't reduce, that stays 8 to 3. And this goes 5 to 2. So obviously these are not equal. They're not the same ratio. So this one is not similar either. So again, small, medium, long. So I'm going to put the 2, the 3, and the 4 under here. And all of these reduce to 2/1. So here's my similar one. So when you're asked to determine, are these shapes similar? You're going to make sure that you put corresponding sides. Now, if they don't give you a similarity pattern, then you have to use common sense. The right angle tells me that these are both rectangles. So obviously the longest side, the 20, is going to go over the longest side of the other rectangle. And then 10 will go over the 3. When I reduce both of these, I get 5/1 equals 10/3. That one doesn't reduce. So these are not the same ratio. These are not similar. So there would not be a scale factor for part A if they're not similar. Part B, same thing. They didn't give us a similarity statement to know how they match up. So since they're both right triangles, I'm going to go with longest over longest, medium over medium, and shortest over shortest. Now, make sure you've got all the bigger side lengths from the bigger triangle all in the numerator and all the side lengths of the smaller all in the denominator. You could flip it over and reverse it, all right? But all of these reduce to 6 over 1. 6 over 1, 6 over 1. So these definitely are similar. Now, it's asking for the scale factor. Now, according to the way I wrote my ratio, I would say my scale factor is 6 to 1. But if you did small over big, you're going to tell me 1 over 6. So there needs to be direction. We need to be told that we're going to go largest to smallest. All right. Or the picture would have to be labeled in a way like maybe this was, this would be A and this would be A prime. All right. We'll talk more about that when we get to dilations. But for now, the other way to do it is to always do, I'm going to say prime over original. All right. Prime over original. So look at how things are labeled. And you always want the second picture over the first. Okay, so we've got 6 to 1 in this case. All right, so either you have to be told the direction or prime over original. All right, the last thing you're going to be doing with similar triangles besides determining if they are is finding missing parts. So the directions say find the missing measures given in this isosceles trapezoid. They are similar, so we know that. And we're told the measure of angle G is 70 degrees. So I'm going to go ahead and put that in my picture. So it wants us to find X, Y, the measure of angle C, and the length of AB. So let's solve for our variables first. So when I look at this, all right, here's my similarity statement. So I know side AB, the X plus 1, is going to go with side EF, which is the 2.4. I'm going to work my way around. I know the 12, which is BC, is going to go with FG, which is Y. And then the last side I see is AC. And AC goes with EG. That's a typo, folks. This should be a D. Let's correct that. Can't have two C's. So AD goes with EH. Now again, I've got 3 ratios, but to solve a proportion, you can only use 2 at a time. So obviously I can't use these 2 that have both the X and the Y in it. Not going to happen. So I'm going to have to pull the X plus 1 over 2.4 and match it with the 5 over 2. Now I can cross multiply and just solve for X. So I've got 2 times the quantity X plus 1 equals, and then 5 times 2.4 is 12. So 2x plus 2 equals 12. Subtract the 2. Divide by 2. So x is 5. To solve for y, I can't use the ratio that has the x in it. So I'm just going to do these 2, recopy it down here. So when I cross multiply, we get 5y equals 24. Now, when I divide that out, I am going to use a decimal because decimals were used in the original. So I get 4.8. We also want to find the measure of angle C. We're using my pattern. C goes with G. And since we were told that angle G was 70, that's what angle C will be, 70 degrees. And then the length of AB is X plus 1. So I need to substitute in the X that we got, which was 5. And so that's going to end up being 6. Okay. Now let's talk about overlapping triangles. When you look at this, it's real easy to say, okay, this height of x goes with this height of 30. And then we have a tendency to say, okay, then the left is going to go over the right. The problem is we need whole parts. So there are two pictures in this, two triangles in this picture that are similar. If I separate them, I've got the bigger one and I've got the smaller one. So you'll notice I'll do the smaller one first. I know the height of the smaller one is 30. And then this base, this other leg, I should say, is 25. When I do the larger, I can see that this height, this leg is x. But the whole side of the larger triangle is not just the 10. I need to add these together. So please be very careful when you see a smaller triangle sitting inside a larger one and they're overlapping. You have to remember that we need whole parts. All right, and then once you have it set up, we can put corresponding parts together. So now I know that the x goes with the 30 and the 35 goes with the 25. And I can cross multiply. So we'll have 25x equals, and 30 times 35 is 1,050. And then we'll divide that by 25. And we'll get 42. All right, so this leg, this height of the larger triangle is 42. All right, so you're working on scale factor, on identifying if shapes are similar, and finding missing parts of similar figures. All right, you should be ready to do your practice.